This is problem number 5 off the ACT practice. Problem number 5 typically is an intermediate algebra problem. Problem number 5 is usually correctly received by students that score between a 28 and a 32 on the ACT. Problem number 5 is part of the expressions, equations, and inequalities portion of the ACT math portion. Okay? If you remember problem number 5, it talks about a neighborhood program serves 280 children who are ages 11 or 12. The sum of the children's ages is 328 years. How many 11-year-olds are in the program does the recreation program serve? Okay, so we have a few things that are going to take place here. We're talking about 11 and 12-year-olds. Okay, so let's call the 11-year-olds, let's call them X, or some variable. We'll call the 12-year-olds another variable that's different. We'll call them Y. Okay, so think about this. If I were to take all of the 11-year-olds and all of the 12-year-olds, how many kids do we have all together with this problem? That would be the 280. So if I take the X, which is the 11-year-olds, and the Y, which is the 12-year-olds, and I added up, I just counted. I said, oh, how many kids are there? 1, 2, 3, 4, and you counted them all up. And they all happen to be 11 and 12-year-olds. We have X and Y being 280 total students. Now, it does say this, that the sum of their ages is going to be 238, excuse me. 3,238. So what this means is this. Okay, I have an 11-year-old, so that's 11, plus another 11-year-old, that's 22, plus another 11-year-old, that's 33, plus the 12-year-old. It keeps increasing. So we want to figure out, there's only one way this is going to work, that we could have the 11 and 12-year-olds being 280 kids, and all the 11-year-olds multiplied together, and all the 12-year-olds multiplied together, their ages, and added them together to give us 3,238. Okay? So the 11-year-olds we called X. So if I were to multiply all the 11-year-olds together and multiply times X, that's going to give me the total of their ages. And then I'm going to take the 12-year-olds and I'm going to multiply them together. So all the 12-year-olds, so let's say I had 50 12-year-olds, I'm going to go 50 times 12. Okay, that's not part of the answer, but it's just how you'd go. And their ages, if I add them together, if I sum them up, it's going to give us 3238. Now, there's a couple of ways that you can go through this problem. Some of the students that have taken higher math classes see it as a system of equations. They might use a matrix in order to solve it. This is a basic Algebra 1 type of problem, though it comes from intermediate algebra. It's a system of equations, so let's go ahead and plug in and solve. So I'm going to take the very top equation, my X plus Y equals 280, and I'm going to modify it. I'm going to choose, do I want to plug in for X or do I want to plug in for Y? It's your choice. I'm going to get X by itself. So if I wanted to get X by itself on this equation, I have to move Y over. Right now, Y is being added. I have to do the opposite of that, which is subtraction. So my top equation is going to modify to be X is equal to 280 minus Y. And all I did with this top equation is I subtracted Y from both sides. So now we find that we have this relationship. What is X equal to? X is equal to the relationship of 280 minus Y. So if I were to take that X value and I were to plug it into my other equation that I hadn't modified yet, I'm going to substitute a whole portion in order to get something out. So I have 11 parentheses plus 12Y equals 3238. Okay? Remember that second equation was 11x, but now we know that x is equal to 280 minus y. So I'm going to plug in the 280 minus y. That's substituting in. We're going to distribute over the parentheses, so here into here. So 11 times 280, might have to do a little bit of math on the side. So I get 280 and 2800, add them together, and that gives me 3080. So I get 3080 minus 11y plus 12y is equal to 3238. Once we get here, I can combine these two like terms together. So negative 11y added to 12y, okay, is going to give me 1y, which is y. So I have 3080 plus y is equal to 3238. So 380 plus y equals to 3238. I want to get y by itself, so I'm going to subtract 3080 from each side. So 8 comes down. I have to borrow here. That becomes a 1. So 13 minus, that's 5. I borrowed and bring it down, so I have 158. So y is equal to 158. What did we say y was equal to? Y happened to be the 12-year-old. What do we want? We want the 11-year-old. Okay, so we want the 11-year-old. That means that my y value I just solved, okay, so I have x plus blank equals 280. Okay, I knew it was x plus y equals 280, but now I know I have 158 of my y's, so I'm going to plug this in. So I get x added to 158 is equal to 280. Subtract 158 from both sides. Okay, remember it's a balanced equation, so what you do to one side of the equal sign, you have to do to the other side of the equal sign. These cancel. I'm going to get x is equal to, I have to borrow here, that's going to be a 7, that's going to be a 10 now, 2. So it looks like 22. Bring that down, and 122. So I have 122 11-year-olds. I have 158 12-year-olds. If I add the 122 and the 158 together, I'm going to get my 280, which should happen. And that's how you go through that problem. So it's a multi-step type of problem.